Hey guys, good morning. Welcome to the Fundamentals of Aerospace Engineering lecture series. So today we'll see the study of atmosphere. This is Professor Nehru, Department of Aerospace Engineering, SNS College of Technology. So last few classes we have seen about the aircraft components and the parts and engines, other thing. So after designing an aircraft or manufacturing of aircraft or airplane, so we have to fly this component in the atmosphere. For that, we have to studying the Earth atmosphere is a multidisciplinary field that encompasses various scientific disciplines, including atmospheric science, meteorology, climatology, and environmental science. Here, an overview of what the study of an atmosphere is having, like the layer of atmosphere, like a key area of study, which is includes all the factors and tools and technique and measuring the atmosphere condition and application and its importance. So coming to the layer of atmosphere, the Earth atmosphere is divided into several layers based on temperature variation and composition. See, in that category, first layer is from the ground level. First layer we call it as troposphere, second stratosphere, third mesosphere, fourth thermosphere, and finally we call it as exosphere. So in troposphere, mostly are the balloons, aircrafts, gliders, the other flying machines is flying in this layer. Whereas in the troposphere, stratosphere, all the asteroids, all the other flying like atmospheric variation. Here there are hot balloons and high altitude aircraft will fly in the stratosphere. And coming to the mesosphere, the rockets, satellites, and the other layers of asteroids are flying in this region. Coming to the thermosphere, here the high temperature region. So some satellites will place over the thermosphere to measuring the entire Earth condition, and out of this thermosphere we go into the exosphere. That we see the all the each layers and its important components. So here we are seeing the Earth atmosphere structure of the from the Earth. So 0 to 12 kilometer up to 18 kilometer, that is 39,000 feet. We call it as troposphere. From the troposphere, 12 kilometers to 50 kilometers from the Earth, that is 16,400, 1,64,000 feet. We call it as stratosphere. So in the end of the stratosphere, we have the ozone layer, where the ozone layer will protect from the different radiation from the sun. So next layer is mesosphere. It starts from the stratosphere of 40 to 50 kilometer up to 80 to 90 kilometer. So next is mesosphere. There is a ionosphere layer will be there. So it is from the Earth. It is to 80 to 90 to 800 kilometer. So if I there in the mesosphere, we have the Indian space station, that is the International Space Station, up to 400 kilometer from the Earth region. So next is thermospace. It is the thermal layer where high temperature is having in the layer. Finally, we go to the exterior space. We call this a exosphere. The layer of the atmosphere. First one is troposphere. The altitude is 0 to 12 kilometer, higher near the poles and lower to the equators, that we know from based on the Earth shape. The characteristics of this troposphere is containing most of the atmosphere mass and its where weather phenomena occurs. Temperature decreases due to altitude in this region. Coming to stratosphere, up to 12 to 50 kilometer. Here, the characteristics containing the ozone layer, which absorb the block ultraviolet radiation from the suns. So temperature decreases with altitude due to the absorption of UV radiation by the ozone layer. Next one is mesosphere. The altitude for the mesosphere is 50 to 80 kilometers. Here the temperature decreases with altitude. This is where most meteoroid burns up on the entire Earth atmosphere. This is a region where the asteroids, all these things, and get in fired out. So at next going to the thermosphere, some 80 to 700 kilometers, temperature decreases with altitude due to the absorption of solar radiation containing the ionosphere where the ionization of gas occurs. Next is finally we go to exosphere. Here the altitude is 700 kilometers and thousands of kilometers above from the earth, and the characterization outermost layer of this atmosphere transition into space. Particles are sparks and gases are escape into the space. So key research areas are we find in the meteorology. Here the focus of study of weather patterns, atmosphere phenomena and their impact on earth surfaces and human activities. Methods observational or data collection during the various weather seasonal to measure the weather station from the satellite or the weather station. The numerical weather prediction modes are calculated. Let us take seen from the picture. We have different the climatic condition in different seasonal comes over the regional geographical region. This data has to be collected either from the weather station or from the satellite for the future usage. Next comes the climatology. Here the focus of this climatology, long-term patterns and trends in the weather and climatic conditions is the main focus of this climatology. And methods, the various analysis are from the different historical data, and data will be predicted for the future climatic scenarios or the cases. So key research area, and third one is atmospheric chemistry. The focus on this atmospheric chemistry is chemical composition and reaction within the atmosphere, includes pollutant, greenhouse gases, and ozone depletion. The method of these things are measured by the laboratory experiment, atmosphere measurements, and modeling. Coming to the atmosphere physics, this focus on the physical process in the atmosphere, including radiation, thermodynamics, and dynamics inside the atmosphere. The calculation are made, the mathematic modeling, observation studies, satellites and remote sensing data can be analysis. Environmental impact focus to study how the atmosphere changes affects ecosystem and human health and global climates. Methods. Field study, impact assessment and policy development can be done in the environmental impact. So coming to the tools and techniques were used to measure the atmosphere condition is the remote sensing, weather balloons, climatic models, and atmosphere probes. So remote sensing, we have the stations, satellite station, ground-based stations, where we can measure all the temperature, humidity, density, and pressure during various conditions and weather pattern and the temperature pattern we can sense by the remote sensing. Weather balloons carry a lot of measured temperature, pressure, humidity, and wind speed and direction at various altitude. Climatic models, computer simulation that integrated data at atmosphere process to predict future climatic trends and scenario. These models will be helpful. And atmosphere probes, instruments deployed in the atmosphere are launched into the space to gather direct measurement of the atmosphere property. These are the tools and techniques and used for measuring the atmosphere condition. An application and an importance of this understanding or studying of the atmosphere layer. First one is weather forecasting, climatic change research, air quality measurement, space exploration. Here, the space exploration, we aerospace engineering will have to study the atmospheric condition to design various aircraft and various power plants. So first coming to the weather forecasting, predicting short-term weather patterns and several weather patterns to aid in the disaster preparedness and the daily planning. So this has to be very important in the current scenario. The climatic changes research, understanding these causes and impacts of global warming, sea level rises, shift in the weather patterns due to human activities. So climatic change is a major problem nowadays due to the global warming. Even the Arctic icebergs are getting melted. This makes the climatic changes and sudden heavy rainfall and heavy high temperature and the heat strokes are making. For this reason, you have to understand, or you have to study the atmosphere layers. Coming to the air quality management, monitoring and regulating pollutants to protect public health and reduce environmental impact. So this air quality is measured by the government and the weather station, and they have to say that this regional based healthy quality air is there. In Delhi, we usually see in summer and in the winter case, the air is not that much quality. In major metropolitan cities, the air quality is very low in India. That things we are understanding that due to the global warming or the people activity, human activity, this air get more polluted, and this makes the serious issue to the public. So for that also we need to understand the air quality management of different regional. So coming to the space exploration, studying atmospheric condition on other planets and moons to assess the habitability and the atmospheric dynamics. And if you understand all the things in the atmosphere, then we can able to design such a flying machine which is more suitable to different planets like Moon, Mars, or Earth, or other planets. For that, we have to study this atmospheric condition. In conclusion of this class, the study of Earth atmosphere is critical for understanding the dynamics of weather and climate, atmospheric chemistry, and environmental impact. It involves a wide range of scientific disciplines and utilizes advanced tools and techniques to gather data and make predictions, which helps to understand whether this rain will come or not, this flood will come or not. These things we can measure. The research in this field contributes to our ability to mitigate environmental risks, improves weather forecasting, and understanding the broader implication of human activities on our planet's atmosphere and the climate. So, thank you so much for this attending this class. So we'll see in next class on a different topic. Thank you.